For this problem, we have an angle bracket which is built into the wall there at end O. We have a force acting at point B in the x direction. We have a force acting at C in the negative y. We also have a couple about the negative z axis acting there at C. Our goal here is to determine the reactions on the bracket there at end O. To draw our FBD, we're going to be seeing reaction forces of OZ and OX and OY. In addition, we're going to have, since it's a wall, it's going to have a couple with all three components of MOX, MOY, and MOZ. So, we'll write down our moment equation first about O. There will be the couple at the wall there of MO. We'll have a vector which goes from O to B crossed with the force that's acting there at B, that's PI. We have the vector which goes from O to C crossed with the force of minus PJ. And then we have the minus MK. That resultant moment must be equal to a zero. So we're going to have MOX in the I, MOY in the J, and MOZ in the K. The vector which goes from O to B, that's going to be 9D in the I. It's 3D in the minus J. So that gets crossed with PI. ROC, that's going to be 9D in the I. It's a minus 3D in the J. And it's a 3D in the K. That is crossed with the minus PJ. And of course, we have the minus MK. So whenever I cross those vectors, I will group together my I, J, and K components. The I components I get are 3PD plus MOX. That's in the X direction. I simply have MOY in the J, and then I have a 3PD minus 9PD minus the applied couple M plus the reaction component there of MOZ in the K. So therefore the I components tell us that MOX is equal to minus 3PD. The J component, that tells us that MOY is a zero. And the Z component of that moment equation tells us that the Z component of the reaction there at O is equal to the applied couple there of M plus 12PD. For equilibrium, we also write down summation of forces equal to a zero. So I have OXI, OYJ, and OZK. I have PI, that's the force there at B. I have the minus PJ. For equilibrium, that is a zero. And the I components tell us that OX is equal to minus P. The J component tells us that OY is equal to positive P. And the Z component tells us that the reaction force in Z is a zero, which makes sense. There are no forces being applied to it from the outside world in Z. And how we got here was really just writing down our moment equations, looking at our FBD, looking at our moment equation about, oh, we had four parts there. We did the R cross Fs. We ended up with three components. We were able to find the reactions at the wall. We summed forces in X, Y, Z, and that gave us our equations for the X and Y and Z components of the reactions there at the support point B.